Good afternoon. It is myself Dr. Gangadhar H. Hugar, Department of Applied Sciences, Chandigarh College of Engineering and Technology, Sector 26, UT Chandigarh. Feel proud to throw some light on refractories, types of refractories and general manufacturing methods of refractories on this topic in the today's lecture. So, in today's lecture we are going to discuss the following points. They are starting from the definition of refractory and how the refractories are used and classified based on their properties or some properties, general manufacturing method of a refractory, general properties of a refractory and general characteristics of a good refractories. These are the points which we are going to discuss during this lecture. So, we will start with the definition. Let us start with the definition of a refractory. General definition, if I just make out a general refractory definition, any material or material which is chemically inert and can retaining their mechanical strength under heavy load even at high temperature without undergoing any deformation is called a refractory material or simply called as a refractory. Okay. So, or else we can also define a refractory as an earthy ceramic material of low thermal conductivity that is capable of withstanding extremely high temperature without essential changes may be called as refractory. Suppose if to throw some light on this or to elaborate this, what are the meaning of this refractory definition? You just see here, you have studied in the previous class, that is first semester, that manufacture of steel by open arc process, LD process and manufacture of the iron from hematite ore, okay, using blast furnace. So, this is a picture of blast furnace and you must have drawn this type of figure when you are studying the manufacturing of iron from hematite ore. There you have also mentioned this lining as either fire clay bricks or refractory lining. So, if you recollect, and these are the materials which are simply a brick and which are they are not simple bricks, they are what type of bricks? They are made up of earthy or ceramic materials which have low thermal conductivity and capable of withstanding extremely high temperature without essential changes without any essential changes or deformation. So, look at the blast furnace, you have studied in the previous classes. There was a temperature, there will be a temperature around 1700 to 1800 degree centigrade at the bosses, near the bosses or hearth, near the hearth of the blast furnace. As you go up, the temperature gradually decreases. So, at that temperature, the material with which the steel furnace is built and lined inside, depending upon the type of impurities that are present in the ore, we have different types of linings. So, those linings which we are of great importance in today's lecture and they are nothing but refractories. So, I reiterate or redefine. So, what is a refractory? A refractory is an earthy ceramic material of low thermal conductivity that is capable of withstanding extremely high temperature without essential changes. Okay, that may be defined as a refractory, or any material for that matter which must be a chemically inert and retain its mechanical strength even at a heavy load at high temperature without undergoing any deformation. It should not lose its shape even at a high temperature. I have taken this as one example, even glass, ceramics, etc. they are produced from the earthy properties. Okay. So, definition. So, the primary use of any refractory is for lining steel furnace, coke oven, glass lens and other continuous high temperature applications. So, we need to take materials which can withstand very high temperature, okay, without undergoing any deformation. Okay. So, that is a more important aspects of any material and which we can call it as a refractory. The outstanding property of these material is their ability to act as a insulator. It is thermal insulator, electric insulators, etc. So, not at ordinary temperature, at very elevated temperatures as high as 3000, as high as 2000 degrees Celsius, as we have seen in the previous slides in the furnace. It is one example furnace. So, like that you have blast furnace and open hearth furnace, okay, LD process, mesmerization process, etc., etc. So, some of the examples what we can quote for refractories are fire clay. Here is a fire clay, we have sand, we have chromite, we have magnesite, etc. So, these are the examples. Examples are fire clay, mainly consisting of aluminum silicates or complexes. These are not so simple simple chemical compounds as like that of sodium chloride, common salt, etc. So, these are very complex silicate compounds, mainly aluminum or alkali or alkaline earth metals silicates. So, silicate, this is SiO2 is essentially present in the matrix in the ceramic and as well as refractories. So, fire clay, where do we use? We use it in the construction of a furnace, kiln, oven, fireplace places, boiler inside, so etc. Sometimes. So, therefore, therefore, this is a refractory example. Silica refractories are used in lining of furnaces of arches, crowns and higher parts of the furnaces and kilns. Chrome and magnesite, that is chromium oxide, magnesium oxide silicates or chromium silicate, magnesium silicate complexes, which are used in the form of a bricks, find extensive use in acid as well as basic open hearth furnace in making the hearth, roof side walls and pots. So, okay. So, these are the applications of refractories. Based on the applications, we have defined the materials as they are either obtained from the earth or they are being modified, the material taken from the earth, and they are such materials which are having low conductivity, thermal conductivity particularly, and can withstand very high temperature without any essential change. So, that is why we can call such materials as a refractory. So, examples I have already told you: fire clay, we have silica refractories, chrome and magnesite refractories. As you said, chromite. So, it is a ore of chromium and magnesite is ore of magnesium, and this is oxide ores along with the silicates. So, therefore, I have written a simple equation here. It is not mandatory that it should have a same chemical composition as written here. It may vary from the source to source, but general composition will remain same. So, and so far as these type of refractories are concerned, and they are used as per the requirement depending upon the open hearth to be used for manufacturing of steel, where we can, what type of slag we are going to get. You have studied this one, no, in the previous classes. How do you decide the refractory lining here? That totally depends upon the molten iron, what is the slag which is coming out of the furnace. Based on the properties of the slag which is coming out, we have to design the internal lining of the furnace. The outer surface is built with the steel, but inside we have to line it with the proper refractory material, and that refractory material is so selected which is not only based on the fact that it should give support and can withstand high temperature, but also it should not react with the any slag which is coming out of the furnace and even at that prevailing temperature, that is say whatever the temperature under which these ceramics or the refractory materials are being used. So, that is the reason why we give due importance, because the primary use of any refractory is lining steel furnace. Okay. So, that is the reason we have to emphasize the fact that they should have excellent insulating properties, thermal insulating properties. Okay. As we progress, we will see different types of refractories. Okay. Now, see, there are some metals characterizing the ability to withstand extremely high temperature. For example, an element called tantalum having atomic number to 73 with atomic mass 181 units, and there is another element called tungsten with a symbol W and atomic number 74, and this which is shown in the picture, they have extremely high temperature withstanding capacity, and therefore, though they are elements, see there, characterizing the ability to withstand extremely high temperature of a tantalum and tungsten, they are also called as refractory metals. So, when we say the refractory, it is not a simple element as that we are seeing, but these elements are regarded as a refractories because of the fact that they can withstand very high temperature. That is the one primary concern about the refractories, as a result of which we can call these metals, even though they are pure metals which can withstand extremely high temperature, hence they are called as refractory metals. Clay, excellent example, is another example of a refractory. Clay is a refractory obtained from the earth, and ceramics are used to mix the refractories, mixture. So, ceramics are those which are the mixtures of refractories. It is not a simple one refractory, it is a mixture of refractories will make another material called ceramics. So, what we can say, ceramics are refractory mixtures. So, this is about the definition of a refractories, and in India. So, as per the data obtained from the Geological Survey of India, we have rich resources of chromite, which is again regarded as one of the important refractory, which we are going to discuss in the classification, and we have magnesite, we have silicates, mica, etc. But one such, to illustrate you, to educate you about the resources which are available in India. So, I have taken one only map. So, here we are the places where we can see there are rich sources of chromite resources in India. Likewise, we have different places where the magnesites are available and silica, etc., which are also important raw material for the manufacturing of or converting them into a refractories. So, India is a rich resource, we can say. Now, we will come to the second part of our discussion. The second part is that classification or the types of refractories. The refractories can be classified, on various bases. So, whenever you want to classify anything, you need certain principles. So, based on certain set of properties, we are going to classify even refractories as well. So, what are those? It may be a chemical nature of a refractory, because we are studying in chemistry and chemical composition becomes very important. Therefore, we have given first priority that for mechanical engineering some mechanical properties which are looking at it. So, therefore, primary is chemical nature. So, chemical nature, so there may be acidic refractories, there may be basic refractories, and there may be a neutral refractories, and so these are three important types of refractories which are based on the pure chemical nature. Chemical aspects are taken into account. So, how do you define acidic refractories? How do you define acidic refractories? Okay. So, as the name itself suggests, these acidic refractories are such refractories or those refractories which are attacked by basic slags. See, acid react with a base to form salt and water, that simple logic, neutralization reaction. So, therefore, if any refractory, any material which you are using as a refractory, if it can react with the basic compounds, then it can form a slag, basic slag, and it can undergo deformation. So, those refractories which are attacked by the basic slags, that is bases, are called as acidic refractories. And you see, the main constituent of this class of refractory is a silica. See the formula SiO2, Si is silicon and it is oxide of like carbon dioxide, both are belongs to carbon and silicon belongs to same group, and this is comes in the periodic table. So, that is in the P block. In the P block, it means that this is a non-metal oxide. You have studied in previous classes, non-metallic oxide are generally acidic in nature. So, that is why silica is important constituent of certain refractories, and if this becomes a major component, then we can regard it as an acidic refractories, because this is an acidic oxide, it is an acidic oxide. So, the main constituent of this class of refractory is silica, silicon dioxide. What are the examples? We have, as I have shown you in the previous slides, we have this is we have fire clay. Fire clay, look at the composition, aluminum oxide with a X silicon dioxide there. So, this is, and therefore, we have the acidic refractories, and the examples fire clay bricks, high alumina brick and silica, quartz and Genster sand, semi silica, alumina, kaolite and dispar. So, these are the examples of acidic refractories. Look at this, these refractories vary widely in their chemical, physical and mineralogical character, depending upon the nature and proportion of silica and alumina. So, based on the portion of the silica and alumina, these refractories vary widely in their chemical composition, physical properties and mineralogical characters. So, and one thing very important about the acidic refractories is that, and these acidic refractories should be avoided or should not be allowed to come in contact with the basic products, because as you know, these themselves are acidic. When they come in contact with the basic, then they undergo a neutralization reaction, acid base reaction. In order to avoid this, we are supposed to use acidic refractories in mostly acidic conditions, so that it will not be coming across with the bases so as to react with sorry, the material. If it starts reacting with the slag, then the lining for which you have developed to sustain the thermal ability, and that will be at stake, means it will not be solve our purpose, and therefore, you are facilitating to react with the bases. Therefore, we are not going to use these refractories, and in the such products where we will have the product character or nature is happens to be a basic one. So, therefore, I repeat, these refractories are not allowed to come in contact with the basic products in order to prevent a possible the acid base neutralization reaction. Okay. The first way of classifying is in chemical nature. We have finished about the chemical refractories, one chemical refractory called acidic refractories. Okay. So, when we say one is acidic, obviously the second will be a basic refractories, and in the similar way you can define, as you have defined the acidic refractories, in the similar way you can also define basic refractories. What are basic refractories? Those refractories which are attacked by acid slags or acids are called basic refractories. For example, look at this alumina. Alumina is also called as the the alumina which is corundum, and carborundum is different, corundum it is. So, this alumina, dolomite, that is calcium carbonate and magnesium carbonate, when it is subjected to calcination, you will get a calcium oxide and magnesium oxide, and that is mixture, it is called dolomite. Magnesite or magnesia, magnesium oxide, chrome magnesium, chrome and magnesite. So, this is chromium oxide and magnesium oxide with the silicon composition, silicate composition. So, these are the example. When you look at these examples, look at, see the composition. Aluminum oxide is a metal oxide, calcium oxide is magnesium oxide, again metal oxides, chromium magnesium oxides. So, metal oxides. Okay. So, therefore, whenever you see the examples quoted here, they are metal oxides. You have studied in previous classes that a chemistry of metal oxides, they are generally they are basic in nature. So, that is the reason the composition will determine its chemical nature. So, therefore, mainly they are composed of metal oxides, and hence these refractories are categorical, we can place them under the basic refractories. Okay. This is the simple trick by which, of course, this is a determined chemical composition has to be determined qualitative quantitatively, and then only we can decide where we have to place, but by looking at the metal oxides we can definitely say it is a basic refractories. So, in most of the cases these refractories vary widely in their chemical, physical and mineralogical character depending upon the nature and proportion of the metal oxide and silicates. Here metal oxides, in the previous cases it was silica and alumina which determines the chemical, physical and mineralogical character of a acidic refractories, but in case of basic refractories it is the metal oxide and the portion of the silicates which are present in them, they are determines the characteristics of that particular basic refractories. And you know, coming to the uses, see, one has to be very cautious, as you know that there is acid base reaction, this is basic and we should not allow it to come in contact with acidic products. As you know, as you go for acidic products, what will happen? It will tend to react with the base to form salt and water. So, that is why we will not use the basic refractories in that situation where the products are in acidic in nature. So, that has to be pre-planned whenever we make a lining in a big furnaces. Okay, that is one of the important criteria. If we know the properties of this refractories, it would be handy for us to develop the good furnaces. Okay. So, the third important chemical refractory is neutral refractories, and as you know the basic refractories are attacked by the acids and acidic refractories are attacked by the bases. So, when you say neutral, then it is neither attacked by the acid nor it is attacked by the base. So, those refractories which are neither it should be either attacked by the slag nor by the basic slags are called as neutral refractory. There must be some neither attacked, it should be neither. So, neither attacked by the acids nor by basic slags are called as neutral refractories. For example, chromite. So, chromite is a silicate of chromium and simple graphite. Graphite is another refractories. Artificially produced refractories such as carborundum. Carborundum is nothing but silicon carbide obtained by heating strongly in an electric arc furnace with sand and coke. So, you will get a carborundum. It is a very special type of refractories which we are going to discuss, and it has many applications, and this is expensive too to produce this one and has excellent refractory properties. So, zirconium carbide, ZRC, etc. These are neutral refractories. Sometimes we can place aluminum silicates also in the neutral refractories, but though it is a basic, sometimes this do appear in the neutral refractories, okay, is placed in this type of refractories as well. And these refractories can be used in conjunction with the acidic or basic products. You can use it anywhere, because these are neither attacked by the acids nor attacked by the bases, neutral. That is why we can use them in either of the cases, right. Okay. Now, the second type of classification is based on refractories. Classification is based on refractoriness, or it is also called as fusion point. So, in order to understand the classification, this is second way of classifying. The first way was what was the first way? The first way was chemical nature. The second is refractoriness. It is one of the important property based on which, or we can simply say a fusion point, fusion point. Okay. So, let us understand little bit about, you are going to study the properties of the refractories in detail in some other lectures, but as we are going to classify on the basis of refractoriness, it would be necessary for, it is necessary for us to define what is refractoriness here. So, fusion point, it is the temperature at which refractory fuses, is called refractoriness. Okay. If I made some certain cone like this, it is one particular test that is called pyrometric cone equivalent test. So, we make a particular, say I want to test this is my test ceramic or the refractory, and I make standard ones cones and I will subject them to heating. So, and then they start melt fusing due to their own weight. Okay. So, refractoriness is the temperature at which refractory fuses, is called refractoriness. It should be much higher than the operating temperature. I am using this material, this refractory somewhere else, what for? To sustain high temperature. So, if it starts melting before the temperature which I wanted to achieve in the particular furnace, then I cannot use that refractory. So, that is why we are written here. Here the temperature should be much higher than the operating temperature. It should fuse at very higher temperature than the operating temperature, okay, of the refractory. Fusion temperature decreases when refractory is under load, and this is called refractory under load, RUL, refractory under load. So, what is that? When we subject the refractory to heating, and then the fusion temperature decreases, and when you apply a load on that, and that is called a refractory under load. So, which can be, so refractoriness can be just obtained by a test called pyrometric cone equivalent test. There are some other tests as well, German, and I am just taking only one. So, PCE, it is the temperature at which a refractory will deform under its own weight, is known as its softening temperature, which is indicated by pyrometric cone equivalent test. Refractories will melt over a range of temperature due to their complex chemical nature. Why they will not melt at a particular temperature? Because they do not have fixed composition. From this point we can say that if it has a fixed chemical composition, for instance you take sodium chloride will melt at a particular temperature, but not the brick or something like that, because brick is not composed of only one chemical compound. It is not, it is a very complex. That is why these refractories are very complex in their nature, in their chemical nature. So, refractories will melt over a range of temperature due to their complex chemical nature. Hence, the pyrometric cone equivalent test is the equivalent standard cone which melts to the same extent as test cone, is known as pyrometric cone equivalent. So, we will just use this test, and the elaborate studies are beyond the scope. Therefore, I just wanted to define the refractory